Ransom note. In this problem, we're given two strings, ransom note and magazine, and we need to return true if ransom note can be constructed by using the letters from magazine and false otherwise. So in example 1, we have a string, ransom note, which is equal to A, and we have a string magazine, which is equal to B. Can we use the letters of magazine to construct our ransom note? No, since we can't use any of the letters in magazine to construct A. In example 2, ransom note is equal to AA, magazine is equal to AB. Although we do have an A in magazine, we only have one, which is not enough to construct our ransom note, which contains two A's. In example 3, our ransom note is equal to AA and magazine is equal to AAB. Now we have two AAs, which are sufficient and enough to complete our ransom note. And obviously we ignore the B, we don't really need it. So the way we're going to solve this is we're first going to create two maps. So map that stores as a key value pair character to integer. So character, integer, we can call this map rn for ransom note equals to new hash map. And a second map, character to integer as well, map for magazine equals new hash map. So I'm creating two maps because the first thing I want to do is I want to store the characters of ransom note and magazine in their respective maps, but these characters are going to be our key, and for a value integer it's going to be their frequency or the number of times they appear within ransom note or magazine, because what we're going to do is eventually we're going to loop through our keys in ransom note, and what we're going to do for each key is we're going to check if the magazine map contains that key. If it doesn't, then return false, but if it does, then we're going to compare the number of times that that key appears in magazine to the number of times that it appears in ransom note. If the value at magazine is greater than or equal to the number of times that it appears in ransom note, then that's good. Otherwise, if ransom note contains more of the same letter than magazine does, then like in example 2, we cannot construct ransom note, so we have to return false. So let's go ahead now and fill up our maps, and the way we're going to do that is for every character ch in ransom note dot to char array. So we're going to convert our string to an array of characters, and then we're going to loop through each character in this array. And what we're going to do is we're going to put as a key the character which we're on, and as a value we're going to put map rn dot get or default that character or 0 plus 1. And before I explain this, I'm just going to copy this code and do the same thing for the other map, which is magazine, and then this is just M, and yeah. So we've seen this code now multiple times on this channel. This is how we're going to account for the frequency of the character which we're on. What we're going to do is for each character that we're on, we're going to put it as a key in our map. Oh, I need to fix this here. So this is actually map rn, and this is map m. So as I was saying, we're going to put the character which we're on as a key in our map, and as a value, what we're going to do is we're either going to get the value of the character which we're on if it already exists in our array, in our map, and then we're going to add 1 to it to account for the current character which we're on. And if the character doesn't exist, then we're going to default to 0, and we're going to add 1 again to account for the character which we're on. So to illustrate in example 2, map rn.put character, we're going to put A, and then map.rn.getter default ch 0 plus 1. Since our map is initially empty, then we're not going to do map underscore rn.get. We're going to do map underscore rn or default 0. So we're going to give it a value of 0, and then we need to add 1 to account for the A which we're currently on. And then in the next iteration, the next A, we're going to overwrite the first A that we put. And since our map already contains a value for A, which is 1, which we just found previously, we're going to map rn.get character, which is 1, and then add 1 to account for the second A. Okay, so now what we're going to do is we're going to create a boolean called flag, which initially is equal to false, and we will be updating it. And we're going to loop through all the keys. So for every int key in our map rn.keyset. So what we're going to do in this for loop is we're going to compare the characters in ransom node, which are now stored in our map rn. We're going to check if these characters exist in map m, and if they do exist, we're going to compare the number of times that they appear in both maps. Like I said, if it appears more time, if the character which we're on appears more times in map underscore m than map underscore rn, then that's completely fine. Otherwise, we don't have the sufficient amount of characters to construct the ransom node, and that's not fine. So let's go ahead and begin comparing. So if map underscore m dot contains key, we're gonna do something. But if it does not contain that key, then instantly we just need to return false. Now within this if statement, we're gonna so if the magazine map does contain that key, we need to see if that key appears more time in magazine map than a ransom node map. So if map m dot get key is greater than or equal to map underscore rn dot get key, then we need to update our flag to be true. And then otherwise, if it's strictly less than the value of map underscore rn.get key, then we just instantly need to return false. We don't return true here because we need to loop through all the elements in our ransom, or all the characters in our ransom node. And then finally, we need to return flag. So let's submit our code and see if it works. Okay, so we got the wrong answer, and that's because I messed up here. Our map rn contains key, which is a character, not an int. So this has to be character actually. Let's submit again. Yeah, and there we go, much better. So that was the ransom node problem on LeetCode. Not the hardest problem in the world. I hope you found that video helpful, and thanks for watching.